Hi everyone, this video is on exercise 13G question 1. So in this exercise, we are still going to find the areas under the curve, but the difference is that it's no longer like the previous exercises that we simply find the area under a curve that is bounded between the curve and the x-axis. So now we are going to have some other things such as lines, and then that means we sometimes need to find the area between the curve and the line. Sometimes it's going to be a combination of the curve, line, and even the x-axis. So at this point, we should be very careful because it's very important to how we need to set up the integral. So in this question, we have the curve with the equation x squared plus 2, and also a straight line with the equation y is equal to 6. So in part A, we want to find the coordinates of the points A and B. So that's a very simple question. Basically, we just need to find the points of intersection, and that happens when x squared plus 2 is equal to 6. So x squared plus 2 is equal to 6. Now we just need to solve this equation. X squared is equal to 4, which means x is equal to plus or minus 2. So therefore, the x coordinates, we have found the x coordinates of A and B. So A has x coordinate minus 2 and B has x coordinate plus 2. We just need to find the y coordinate by just substituting into the, we don't even need to substitute because the y coordinate is 6. So A has coordinates minus 2, 6, and then B has coordinates plus 2 and 6. Okay, part B is where it gets interesting. So we want to find the area of the finite region bounded by line AB and a curve. So it's obviously the yellow region. Okay, so for this, in order to find this, we just need to understand the meaning of integral when it comes to finding areas. So essentially, if we integrate basically the line y is equal to 6 between minus 2 and 2, that's going to give us the area that is bounded by the line and the x-axis. So that's going to give us this area. If we simply integrate 6, basically this line is. So this is going to give us the area that is bounded between the x-axis and this straight line. But as you can see, we only want the area of the yellow region. So if we simply integrate 6, that's obviously going to give us some, some parts that we don't want, the white regions. And also, at the same time, if we only integrate the curve, so the curve is x squared plus 2, that's going to give us the area that is beneath of the curve and it's bounded between the curve and the x-axis. So that's going to give us this area. So again, we also don't want that, right? So what we do instead is that we actually want to find this region, the area of the white region, but we are going to subtract that from the area of the part that is beneath of 6, because 6 is going to give us the area of the whole, this sort of shape which looks like a rectangle. And then what happens as a result of that is that we have the total area, but we only want the yellow region. And then the curve is going to give us the area of the part that we don't want. So we can simply just take that away from the total to get the area of the yellow region. Okay, with that said, it's now time to set up the integral and then just solve that. So all we need to do is that we just simply write 6 minus x squared plus 2x. And then we just need to integrate this. Yeah, the reason we subtract is again because we simply want the area of this region. So that's why we just subtract. So we can do the subtraction inside the integral. That's the interesting part. And some of you might be wondering if we can solve two separate integrals and then subtract at the end. And the answer is yes, because we could have also had, as long as the limits are the same, we could have had the integral of 6 between 2 minus 2 minus the part that we don't want, which is the integral of this. So x squared plus 2x, which is the curve. And yeah, so, it's not 2x, sorry, it's just 2. Yeah, so both ways are valid. In fact, it's just a property of an integral that when the limit is the same and everything is integrated with respect of the same variable, you can just combine the two integrals and that becomes a single integral. So yeah. Okay, so for simplicity, I'm just going to use this combined version because that's going to be quicker. Uh, so in this case, we have 6 minus x squared minus 2 dx, which is basically 4 minus x squared dx, and then that's equal to 4x minus the third x cubed, and then 2 minus 2. So at this point, we just substitute 2 and minus 2, and we'll get 32/3. So this is the area of the yellow region. So yeah, we found the total because 6 gives us the total area, and then x squared plus 2 gives us the area of the white region. So that's why we take that away to get the yellow region.